Example number 14. Under the root x minus 1 over x minus 3, I have a square root term in the numerator. This is a square root function and a fractional function as well. So when you look to the numerator, it must be greater than or equal to 0. As usual, anything inside the square root can be 0 or greater than 0, but it cannot be a negative number. So we have to be very careful. In the denominator, we should not have any 0. We should avoid 0, otherwise we will get indeterminate form, which I don't need. So according to the numerator, x minus 1 must be greater than or equal to 0, which means that x must be greater than or equal to 1. It's exactly like x minus 1 equal to 0. So this one will go on the other side, will become positive. And my condition will be x can be 1 or must be greater than 1. There is equality sign, which means that including 1. But what if I do one simple test to try a random value less than 1 in this equation? Let's suppose if x equals to 0, 0 is less than 1. What condition says? Condition says that x must be greater than 1. Can be 1 but should be greater than 1. Cannot be less than 1. I want to try something less than 1, which is 0. 0 is less than 1. When I substituted x equals to 0, I got negative 1. So I will get a negative number inside the square root, which I don't need. And there the test has been failed. Let me take the denominator. X minus 3 should not equal to 0. As I said, if I get 0 in the denominator, I will get indeterminate form. From here, I'm gonna get x must not be 3. This is the second condition. When I substitute x equals to 3 here, 3 minus 3 will be 0, which I don't want. So x should not be equal to 3. If I try x equals to 3 here, I will get 0. As I said, 3 minus 3 will be 0. I must avoid it. So there the second test has been failed as well. Let me try a number line here. This is a number line where at this point I have 0. And then the first condition, 1. And then the second condition, 3 here. I have a fill-in circle for the 1 because of this equality bar, which means that 1 has been included. I have an empty circle with the 3 on the number line because it is pretty clear from the second condition that x is not equal to 3. So 3 has not been included. This 1 is because of the first condition, and this 3 is because of the second condition. Now finally, to determine the domain. My domain will be all real numbers except 3 and less than 1. I can put any real numbers for x other than 3 or less than 1. Because remember, in the second condition, x is not equal to 3. I have an empty circle. So except 3. 3 has not been included. And then less than 1. Because the first condition says that x must be greater than 1. Cannot be less than 1. This is the one way to write the answer for the domain. But what if I put ordered pairs for the domain? I can put it from the number line according to the first condition. X must be greater than 1 or equal to 1. So I will go in the right direction up to positive infinity. And this will be my first ordered pair. But when you look to the second condition, I'm leaving the 3 and will go ahead up to positive infinity. Remember, the first condition says that x must be greater than 1 or equal to 1. So I will go in right direction up to positive infinity. I'm going all the way, but in the middle I have an issue. What is the issue? Issue is the 3, because the second condition says that x is not equal to 3. I will leave the 3 and then will go ahead up to positive infinity. So my second ordered pair will be 3 comma positive infinity. This closed bracket with the 1 is because of the filled-in circle with the 1 on the number line, and then the parenthesis with the 3. I will start from 1. I start from 1 and there is a closed bracket, which means that including 1. Including 1, I will start from 1 up to 3. Up to 3. And 1 and then 1.1, 1.5, 1.9, 2, 2.5, 2.3, whatever, as long as it is less than 3. Up to 3. But this parenthesis with the 3 means that 3 has not been included. I will go more than 3 up to positive infinity, whatever value you put in the right direction. The only issue is with the 3 here. When I start working from here, I will close my eye here, for instance, because I don't need 3. And then we'll cross it without any interruption, and we'll go ahead more than 3, like 3.111, 3.5, 3.6, up to positive infinity. That will be my domain. Whether I write the answer in words like all real numbers except 3 and less than 1, or in ordered pairs, both the answers are correct. But remember one thing, it absolutely depends on your question. If the question asks that simply find the domain, you only put one answer. If the question asks specifically, there may be a question when they specifically ask that write the answer for the domain in words. Then you will need to write the answer for the domain in words. And there might be a question where they specifically ask about the number line method to put in ordered pair form. And there may be a question where they can ask both the answers in words and in the number lines. It depends on your question. It's not compulsory to put both the answers. You can only go with one, whether it is in words form or in ordered pairs form. It's up to you. Example number 15. Under the root x minus 4 or x plus 1. Again, it is a root function and a fractional function as well. In numerator, x minus 4 must be greater than 0 or equal to 0. It shouldn't be any negative number. And similarly, denominator must be greater than 0. It should not equal to 0. So according to the first condition, x minus 4, x must be greater than or equal to 4. This is going to be my first condition. Condition says that x can be 4 because there is equality sign, and then must be greater than 4. It cannot be less than 4. But let me do a simple test. If I put some random value which is less than 4 in this equation, let's suppose x equals to 2. 2 is less than 4. 2 minus 4 is negative 2. I will get negative 2 inside the square root, which I don't need. So I can't go below 4. I must go above 4. And there the test has been failed. In denominator, x plus 1 is not equal to 0, which means that x is not equal to negative 1. If I substitute x equals to negative 1, negative 1 plus 1 will be 0, and then I will get something over 0 which is indeterminate form, and it is invalid. I must avoid of it, so I can't put x equals to negative 1. This will be my second condition. But let's suppose if I substitute x equals to negative 1, I will get 0. I will get 0 in the denominator. Something of 0 is indeterminate form, which I don't need. It is invalid. I must avoid of 0 in the denominator, and therefore x cannot be equal to negative 1, and the test has been failed. Let me draw a number line here, where at this stage I have 0. Then according to the first rule, x must be greater than 4 or equal to 4. So my point for 4 will be here. And then according to the second condition, x cannot be equal to negative 1. And there is my third point, which is negative 1. This field in circle for 4 is because of this condition. Because there is equality sign, x equal to and then greater than 4, which means that 4 has been included. Therefore I have field in circle on the number line. I have an empty circle for negative 1 on the number line because of this condition. Condition says that x cannot be equal to negative 1. So negative 1 has not been included. It has been excluded. And therefore I have empty circle for the negative 1 on the number line. What will be my domain? My domain will be all real numbers except negative 1 and less than 4. I can go for any real numbers except this negative 1 or less than 4. This will be my answer for the domain. Because remember, according to the first condition, x must be greater than 4 or equal to 4, which means that I must go in the right direction up to positive infinity. I cannot go below 4. And the second condition says that x cannot be equal to negative 1, which means that I don't need at all to go below 4, because neither I need it in the first condition nor I need in the second condition. It's pretty clear that I can only go above 4 in positive direction. This is the one way to express the answer in words, and the other way will be the ordered pair, which is 4 comma positive infinity. Let me repeat it again, just to avoid the confusion. As I said earlier, I don't need the second condition, which is negative 1, because it is not included. So I don't need at all to go below 4. I will only go above 4 up to positive infinity. So whatever value I choose to put for the x above 4 or 4, it is valid. I have no issue at all. But if I go below 4 in left direction, I have a problem. In the ordered pair, I have a close bracket because of this field in circle. This is the second way to express the answer, 4 comma infinity. But remember, as I said in the previous problem, that look, it totally depends on your question. If the question asks that only find the domain, you don't need the number line and all this stuff. You can simply straight away put the answer in words. But if they ask of the number line, then you must draw the number line. Or if they ask both of them, you have to go with both. It's up to the question, what the question asks. And it is just for your understanding, I go with both.